Elementary students, in this lesson we are going to be working some problems related to the areas of quadrilaterals. And you'll see in the lower left here I've got some practice problems we're going to be going through related to the areas of quadrilaterals. You see I have some parallelograms. Here I have a rectangle, maybe, or maybe it's a parallelogram, who knows. Down here I have a trapezoid. Then you can see in this one, letter E, it mentions a rhombus. Okay, so we've got these different types of quadrilaterals. We're going to be talking in this lesson about how we can find the areas of these. And I'm going to tell you this. In this lesson, we're not going to prove the areas of any of these quadrilaterals. There are these beautiful proofs that exist that explain how we can find the area of a parallelogram by equation. That one I'm just going to talk about quickly. But also why the formula for the area of a trapezoid and the area of a rhombus are what they are. But we're going to save those. For right now, I just need you to know what the formulas are. These are formulas that you should be able to commit to memory. None of them are really that hard. The trapezoid is the hardest, but none of them are really that hard. All right, let's get started. First of all, let's talk about the area of a parallelogram. The area of a parallelogram is simply base times height. Now look at what the base and the height are. This is the same kind of height that we use for a triangle's height. Notice that we get to choose any side of a parallelogram that we want as the base, but then the height is the altitude from that base, meaning the height is perpendicular to the base, to the other side, to the opposite side of the parallelogram. Now, this is important because sometimes there's problems that will look confusing and you'll be given the base side, but then just another side, another diagonal side of the parallelogram. You won't be given the actual base and altitude height that's perpendicular to the base. So you have to figure out the height perpendicular to the base in those ones. Just make sure you look at this diagram. Look at what the height is. Notice the height is perpendicular to the base. Those are the values you need to know in order to find the area of a parallelogram. Just one other thing to note, the reason that this is the same formula as that of a rectangle is I want you to imagine cutting off this little end triangle right here. And you see how this little end triangle right here, I'm circling it right there. Notice that this little end triangle, if we cut it off and plugged it onto the other side, it would turn this into a rectangle with base B all the way along this bottom base and height H, okay? So really a parallelogram is just a slanted rectangle, and it's slanted in such a way that if we cut off the triangle in one end and move it to the other end, the area would be that of the rectangle that has the same base and height. Okay, that's why it's just base times height. One other thing, remember, there's a lot of shapes that are parallelograms but that have other names. A rhombus is a parallelogram. A rectangle is a parallelogram. A square is a parallelogram. Technically, all of those areas can be calculated with base times height, even though specifically the rhombus has a special equation that we use to calculate its area. So a rhombus can be calculated with base times height if you know the base and height, or it can be calculated with a different formula we'll be learning in a little bit. A trapezoid. This is the hardest one. Okay, a trapezoid is going to have two different base lengths, and the bases are parallel to one another, okay? Notice that the height has to be perpendicular to both bases for a trapezoid. Remember, a trapezoid has one set of parallel sides that are opposite each other, but then the other two sides are not parallel to each other. Okay, and what we're doing is we're noticing that one side is longer than the other. We're going to call one side base 1, one side base 2. The height is the perpendicular that connects the two. And the formula is 1/2 times the sum of both bases times the height. So keep in mind, the order of operations, we have to do what's in parentheses first. We have to add B1 and B2. Now there are some beautiful proofs as to why this equation is what it is. But for now, I'm just going to say, trust me, this is what it is. Okay, we're not going to go into proofs as to why the area of a trapezoid is this formula. but this is the formula. So 1/2 base 1 plus base 2, make sure you do that first, base 1 plus base 2 times the height. And then lastly, there's a special way that we can use to calculate the area of a rhombus. Now remember, a rhombus is going to have diagonals that connect its opposite vertices. You see these diagonals pictured here. One thing we're going to talk about later in the course, we're not going to talk about it right now, but a rhombus's diagonals are always perpendicular to each other, which is a unique characteristic of a rhombus. Remember, a square is a special type of rhombus, so it has perpendicular diagonals also. And we can do a proof from that as to why the equation for the area of a rhombus, this is the alternate, because remember, we could use the equation for the area of a parallelogram if we know the base length and the height, and the height, remember, means a height perpendicular to the base, okay? So it'd have to be this distance here. Or alternatively, if we know both diagonals inside the rhombus, then we just take 1/2 times diagonal 1 times diagonal 2 also gives us the area. 1/2 diagonal 1 times diagonal 2, kaboom, we've got an area of a rhombus. Okay, now let's put this into practice. We are going to work out our lesson practice here. And what I'm going to do is I'm just going to actually bring this to the front, and we'll make this a little bigger so we could actually see it. Okay, so first thing we're going to do is find the area of each of these two parallelograms. Now notice the first one looks an awful lot like a rectangle, but a rectangle is just a type of parallelogram. What I'm going to do here is just base times height. 8 times 14 equals. And if I were to carry that out, 8 times 14, I would find that I get 112, and then because we're measuring both sides in yards, yards squared. All right, over here, very similar situation, except this time my parallelogram is not a rectangle, but that's okay. We can still calculate the area. It's simply going to be 16 times 4, and 16 times 4 equals, up here, let's see, 64 square feet. The next question, find the area of a trapezoid with parallel sides measuring 14 centimeters and 21 centimeters and a height of 13 centimeters. All right, now let's think about that one for a second. I'm just going to work that one out right over here. So this one's going to be 1/2, okay? The base of one, 14, plus the base of the other, 14 plus 21, okay? I'm going to put that in parentheses because that's what we have to do first, times the height, which is 13. So 1/2, 14 plus 21, that's going to be 35. 1/2 of 35 times 13. The answer for that one, 227.5 centimeters squared if I were to punch this into a calculator. All right, here we have another trapezoid, and this one's going to have a similar equation. Notice I'm given all the right sides. I'm given the top, the bottom, base. These are the parallel sides. Okay, that's what I need to know. And then I know a side, the perpendicular height. Okay, this 2 yards is perpendicular to my two parallel lines. That's exactly what I need. In this case, I'm going to change it. It's going to be 1/2, 4 plus 6 times 2. And I might be able to do this. So 1/2, 4 plus 6 is 10. So 1/2 of 10 is 5 times 2. This should be 10 square yards. Let's see if I'm right. Bam, 10 square yards. All right, find the area of a rhombus that has a diagonal lengths of 8 inches and 11 inches. Okay, so here again, we're just going to use one of these formulas. And in this case, I'm going to work it out over here. It's going to be 1/2 the base, I'm sorry, the first diagonal, let's see, 8 times the second diagonal, 11. 1/2 of 8 is 4 times 11. I'm guessing this one's going to be 44 square inches. Let's see if we're right. Yes. All right, so 1/2, 8, one diagonal, 11, the other diagonal, multiply them all together. All right, this one is a question very similar to one that might come up. this one asks us to find one of the diagonals if we know the area. So you have to be ready to do algebra with these, okay? In this case, we know that diagonal 1 is 6 meters. And let's see, this is going to be diagonal 2, okay? And this is going to equal 12. So to find diagonal 2, if the diagonal 1 is 6 meters and it has an area of 12. This is my equation. Let's see, to solve this, I'm going to just copy it, but we're going to get rid of the half by multiplying both sides by 2. That's going to change this to 24. Then I'm going to get rid of the 6 by dividing both sides by 6. I believe that I get diagonal 2 is 4 meters. Let's see if that's right. And we are correct. All right. Dakota needs to put new flooring in the cafeteria of a high school. The cafeteria is shaped like a diamond with 4 congruent sides. What measurements should Dakota take to find the total area of the cafeteria? Now, I forgot to cover this answer, but let's just take a look. Since the Dakota is a rhombus, a diamond is a type of rhombus because the opposite sides are parallel on both sides of it. So since a diamond is a rhombus, Dakota should measure either the base and height. Notice a rhombus is a parallelogram, so if we know the base of one side and then perpendicular to that base, how far is it to the opposite side? That's what we would need to know. Or the diagonals of the cafeteria. Either one of those, we'd be able to calculate the area of the cafeteria.